Welcome back, everybody. Here is a special request video that was I've had a couple students ask me to do, and so I'm a little more formally dressed in this video than I normally might be, with the sweater and the collared shirt. You usually be one or the other. But I did get especially dressed up just for this. It just so happens to be the timing for the video. So let's just go ahead and jump in and take a look at this. The purpose of this one is just to kind of wrap our minds around the concept of molarity. All right, so molarity, we know. Let me go ahead and let me change my color palette here real quick back to something that I like for this. Anyway, we know molarity. All right. So for molarity, what we do is we need moles of solute. All right. So the moles of solute per liters of our solution. So you're going to need yourself, obviously, some sort of something like a beaker to mix your substance. You're gonna, here I just got regular old table salt, sodium chloride. I've got a scupula, got a stirring rod, and I've got some water. All right. So with that said, and then you'll need a balance. Now I have an electronic balance over here, but in class a lot of times we use a triple beam balance. For the purposes of this video, I just need to quickly get a reading over here. So molarity, again, moles of solute, liters of solution. Well, our balances do not measure out in moles. That would be like if you put something at the grocery store on a scale, it would say, it would tell you how many dozen pieces of lettuce you have. It doesn't do that. It gives you the mass, or it would tell you how many dozen eggs you have, or how many dozen tomatoes you put in your basket, or whatever. Scales measure out a unit of mass, or the scales are set for a unit of weight, like pounds or ounces or something like that. So we're obviously going to need to get our measurements, and then we can see here from the equation that we're going to have to do some calculations, or some conversions. We have to do a little bit of dimensional analysis at first and get our units into both moles and a liters unit. So with that said, let's go ahead and get started. Put on your safety glasses, make sure you're safe. I have this balance over here, and so you can do a little bit of mass by difference. So I'm just going to take this beaker, I'm going to come over here, I'm going to put it on my scale, and then I'm going to use the tare function, T-A-R-E, and what that does is it zeroes it out so that it already has the mass of the container in storage. If you were on a triple beam balance, you would obviously just zero it out, get it balanced, right? And then you would move your scale accordingly to however much mass you needed. So right now, I'm just going to take the table salt. I'm going to take the scupula, and I'm going to put some in, and I'm just randomly putting some in. If you were in a lab situation, then you would know what your recipe is. Okay, you would actually know what your recipe is. So I'm just putting a little bit in here, and I have no idea. I haven't done this beforehand. I have no idea what's going to happen with these calculations. I mean, looking at it and understanding the concept, I can get a rough idea, but I'm just sort of randomly putting numbers together here. Okay, so I'm gonna put this off to the side. Over here, you can't see this, but right now it says 5.08. It hovers back and forth between 0.079 and 0.081. So we'll go with 5.08. All right. So right now we know that our mass of salt, so our mass of NaCl equals 5.08 grams. This we know. All right. So now at this point, what we do is we need molar mass. All right, so we know molar mass. If we look back at our periodic table, again, you would go and you would find the mass of your sodium, the mass of the chlorine, and then you would put those molecular weights together. And remember, from previous lessons, we've we've seen that we have a molar mass of 58.44 grams of sodium chloride. And before I make the same mistake that I asked my students not to make, let me make sure my units are 100% correct. So NaCl right here, so that unit canceled out. Okay. So that's per 1 mole of sodium chloride. So now if I multiply all this together, all right, so I got 5.08 divided by 58.44 in the calculator. Let me bring this down. This gives me 0.0869267, and there's a bunch of other numbers. And that would be moles of sodium chloride. So I start off with 5.08. So if we follow sort of standard procedure, we look at that and we go, I'm going to need 3 significant digits. So we'll go with the first 3 significant digits. All right, so the first 3 significant digits are here, here, and here, right? And so then that extra 2 right there, technically, you know, 2 is not going to round anything up. So we have a couple options here. We could keep that here in our calculations and then do some further, then do the rounding at the end. You only do 1 rounding at the end anyway with all of your calculations. But we could keep that 2 in there, and it keeps our math honest. It keeps a lot of precision and keeps our precision and accuracy with our measurements and our calculations kind of in line with each other. And so, but in the end, you should see that you basically are going to get the same answer in this situation here. So we could go with 0.0869 moles of sodium chloride. Check. So right now we've got moles of sodium chloride is 0.0869 moles NaCl divided by liters of solution. All right. Well, let me go ahead and get all this out of the way. And now what we're going to do is now we're going to deal with the liquid part. And this makes me nervous having this right next to my iPad, so I'm going to be very, very careful here. So I have, and you can see here, right? You can see that there's salt that's in there, right? And so now, now what I have to do is we have to get down level here, eye level, and do a really, really good reading. This particular graduated cylinder that I have, each of the graduated lines, the tick marks on there, counts for 1 milliliter. And this, the meniscus on this one is at is between 64 and 65. It's kind of in between it. So I'm going to say 64. Well, it's kind of right on the line. I'm more eye level with it. So there's a 65, 65, 66, 60. It's right at, I said 4. I'm looking, I got lower and I realized I was looking at it wrong. I'm going to go with 67. It's at the 67 milliliter mark. So we're going to come over here, and I know that I have 67.0 milliliters. But we need liters. So we're going to convert this. So we know that there are 1,000 milliliters per 1 liter. Milliliters cancels out. If you divide that out, you basically have 67 divided by 1,000, which is essentially going to take that decimal and it's going to move it 3 places back in the other direction. So we get 0.670 liters. And I've kept my significant digits 1, 2, 3. There are still 3 sig figs in that value. Okay? So that's what I've got right there. Right now I've got 0.0670 liters of solution. And liters of solution, SOLN, is an abbreviation for solution as a unit. Let me erase this, get this out of the way. And now at this point, we have everything we need. I'm going to come straight down on this. We have everything we need basically to figure this out, what the molarity is. All right, so we got 0.0869 divided by 0.0670 That would be 1.29701. All right, now you see here that I have moles per liter. So that is moles per liter, and that's moles of sodium chloride per liter. All right, you typically just write moles per liter, understanding that, and then like on your container, you would write out, you know, the full label of sodium chloride. And then of course this is solution. And so what we typically do is we just take this part right here, and that right there you can see matches up to that. The only thing that changes is which solute are you using. All right. Typically we're going to use an ionic salt. Typically we'll be using distilled water. But your solvent doesn't always have to be water. Sometimes it could be an alcohol, it could be an oil. It just depends on the properties of the substance you're trying to have in solution. Okay? So in the spirit, so we divided here. Remember the rules for sig figs. When you divide, you want the least significant digits total. Even if I'd have kept that 2 earlier up here, it's not going to change the answer that much, but we would still want 3 sig figs, because there's 3 sig figs, and we've got 3 sig figs there, or 4, either way you look at it, right? And so 3 sig figs for the final answer, and so we're going to want 1, 2, 3, and that's 7. This 7 right here, strong argument is going to round that 9 up. So it's going to round this up to 1.30, and then that would be moles of sodium chloride per liter. All right. So moles of solution. Now what we do is this: is we look at this unit right here. We bring it down, and that's a derived unit. Derived means it comes from all of this work here in this calculation. Well, moles per liter, you'll notice that the solutions that we've been using, the ones that I've pre-made for you, they have a capital M written on it. And that capital M stands for molarity. All right? So 1.30 molar. So basically 1.3 molar. So now what that means is I've got this salt, I've got this solvent right here. I pour this into here. I make sure all that gets into there. Make sure I've got a good reading. I take my glass stirring rod, or it could be that you have a stir plate, and you put the little stir rod, magnet rod in there, and it'll stir it for you. And we'll have labs where, you know, to kind of speed things up, you're going to want to do that. But essentially, you just stir all this up, and you just keep stirring and stirring and stirring. And sometimes if you put it into a container, like an Erlenmeyer flask or something like that, then you can put a stopper on it, and as long as you know it's sealed properly, if you use the right type of sealant, then you can sort of wiggle it around just a little bit. Or you could still typically use a stir bar in there. You put it on the machine that's going to stir it, a little stir plate, and it does the work for you while you're over somewhere else doing some other work. Just going to stir this up, and we'll just say that that's all dissolved. We'll put this over here, I'll rinse it out later, and then depending on the concentration you've got, sometimes it could be a little cloudy, but most of the time it's, you know, it's fairly clear. You can see through it. The exception would be if you use something with copper in it, and of course your solution would have like a blue color, like with copper sulfate or something, right? And so now I know that when all this is completely dissolved, that based on these measurements and these calculations, that I now have I have 67 milliliters of a 1.30 molar sodium chloride solution. And I could, if that's what I needed for my lab, that's the recipe that I would follow. So you can see from the equation, you can sort of backwards engineer what you need. So if you know you need a 0.5 molar solution, you just go backwards and realize how many moles of this solvent do I need. I'm going to be using X amount of my solvent. If that's the case, well, you can see here how this is just a basic, simple algebraic equation. If you know you need a certain molarity and you know how many say milliliters you need, understanding that's going to be in a liters unit, you just do your math to solve for moles of solute, just like your just like your math teachers taught you in your algebra classes. And once you know moles of solute, we convert that moles of solute into grams of solute. Go to your scale, measure it out, measure out your liquid, mix them together, stir it up. You're good to go for lab. All right. So there's the basics for molarity. And this works with anything. I don't care what it is, what your solvent is. This is the basic, a basic way to measure out molarity. There is another video that I'm going to make upon request as well that sort of explains a lot more about dilutions, but I'll make that a completely separate video because I have other lessons where I've already done some lessons and we incorporate this into it. And in those lessons, it's assumed that you understand this. So if you ever watch any of those lessons, or you're in class and you just forget how to do molarity and you can't get with me, I'm always right there at your disposal on the channel. All you gotta do is come to this video and watch it and just take notes over and over again. It's good seeing you, good talking with you, great learning with you. Stay curious, and I will see you in another lesson real soon. Go do some molarity. I'm gonna go get some coffee. I'll talk to you later.